So with implicit differentiation, what will happen is that sometimes we have to find dy dx. So we have to work out dy dx where y is for y, which is a function of x. And in this case, the relation between x and y is not explicit. Okay, so what does this mean? What this means is y is not necessarily the subject of the formula, and making y the subject of the formula might be quite tricky to do. So an example of this where y, the relationship between x and y is not explicit, can be given by a function like this. So we have y plus sine y is equal to 2x. And here we still want to work out dy dx. So we can see that with this function here, making y the subject of the formula can be quite tricky if it's even possible at all. Okay, so we call this function here, or this equation here, an explicit equation of y in terms of x. Explicit equation of y in terms of x. So if you have explicit, then y is alone on one side. On the other side, there are no y's, so y is the subject of the formula. Now here, where it is quite challenging to write y as the subject of the formula, that is what we call implicit. Okay, now just because we have an implicit equation does not mean we cannot find the derivative. So we still are able to work out dy dx. Okay, so looking at this very example, we want to find dy dx if y plus sine y is equal to 2x. Now, the way we will work this out is anytime you differentiate a function that involves y, you need to multiply by the derivative of y with respect to x, which is dy dx. So look at it as if when you're differentiating, you're using the chain rule. Okay, so when we differentiate, we have the derivative of y is just dy dx. And then to differentiate sine y, like we said, look at it as if you are using the chain rule. On the outside, you have sine. The derivative of sine is cos. So we have cos. The inside must remain the same. And then when you move to the inside, on the inside, you have y. The derivative of y is dy dx. Okay, and then on the other side, the derivative of 2x is just 2. Then what you do is you are going to collect dy dx. That means you factorize it. So we have dy dx. You factorize. Here it goes there once. Here we have cos y. And this is equal to 2. And then because the question said find dy dx, we have to make dy dx the subject of the formula. So we can see that dy dx, this is equal to 2 over 1 plus cos y. Okay, so the way we find the derivative here with this implicit functions is by applying like a chain rule. Okay, so on the outside here you have sine, then when you move to differentiate anything with y, then you multiply by dy dx. The next one, we want to find dy dx if x y squared plus y x squared is equal to ln of x. All right, so again, we continue with the same idea. We want to differentiate x, y squared. But here, remember, x is a function of x and y squared is also a function of x. So to differentiate x, y squared, I must use the product rule because these two are multiplying. Okay, so we know the product rule. It says the first one, the way it is, and then I multiply by the derivative of y squared. To differentiate y squared, we use the chain rule. So the 2 will come down, and then at the top you have 1, and when the exponent is 1, you don't even need to write it. And then you move inside. On the inside you have y. The derivative of y is dy dx. And then we're continuing with the product rule. The derivative of x is 1, and then y squared the way it is. In this one, we will do it in the same way. The derivative of y is dy dx, and then we multiply by x squared the way it is, and then y the way it is, and then multiply by the derivative of x squared, which is 2x. And then on the right-hand side, the derivative of ln of x is 1x. And then, as always, we say all the terms with dy dx on one side. So terms without dy dx must go on this side. So we have 2xy dy dx plus 2x cubed. It's just x squared dy dx. And then on the right-hand side, I have 1 over x. This one goes this side, so I have minus 2xy. This one goes that side, so I have minus y squared. Okay, then on the left-hand side, we factor out dy dx. So we have dy dx. This is equal to, what's the factorize? 2xy. So try not to skip any steps. Okay, and then when we divide by this bracket here, okay, and then we said we just don't like to have fractions within a fraction. So what we can do is the numerator, we can multiply everything by x. The denominator, we can multiply everything by x. So x times 1 over x, this is 1 minus 2x. Sorry, these are right here. Minus 2xy multiplied by x, we have minus 2x squared y, and then minus y squared times x, this is minus x y squared. And then the same thing in the denominator, 2xy times x, this is 2x squared y, and then x squared times x, that is x. x over y is equal to x squared y cubed plus 1. Okay, so again, we want to work out the derivative dy dx. All right, so to do that, on the left-hand side, we have to use the quotient rule. And then on the right-hand side, to differentiate this one, we will have to use the product rule. So left-hand side, using the quotient rule, we have the denominator the way it is, and then we multiply by the derivative of the numerator. We subtract the derivative of the denominator, and then that is multiplied by the numerator the way it is, and all this is over the denominator squared. So that is the quotient rule. And then on the right-hand side here, we have x squared the way it is, and then the derivative of y cubed. First, we have 3y squared, and then we multiply by the derivative of y, which is dy dx. And then we add the derivative of x squared. This is 2x, and then y cubed the way it is. The derivative of 1 is 0. Okay, and then we proceed the way we do all the terms with dy dx come on one side, the ones without dy dx on the other, and then you'll factorize dy dx and then make it the subject of the formula. So from here, I can multiply both sides by y squared, so I'll be left with y minus dy dx times x. This is equal to, I multiply this by y squared, so I will have 3x squared y to the power of 4 dy dx, and then y squared multiplied by this, I have 2x y to the power of 5. Remember, when the bases are the same and we are multiplying, what I do is I add the exponents. So this one here and this one here have dy dx, so I can take this one over to this side, and then this term here over to that side. Okay, so what that will leave me with is y minus 2x y to the power of 5. This is equal to 3x squared y to the power of 4 dy dx plus x dy dx. Okay, then we factorize dy dx. I'm just going to write it first. So if I factor out dy dx on this side, I have 3x squared y to the power of 4 plus x. And then this one, I write it here. I have y minus 2x y to the power of 5. Okay, and then divide everything by this bracket. That leaves us with dy dx is equal to y minus 2x y to the power of 5 over 3x squared y to the power of 4 plus x. So the next question says, find dy dx at this point 1, 2. So x is equal to 1, y is equal to 2, and this is our equation. Y e to the power of 4x squared is equal to 2x e to the power of y squared. And then it says explain its meaning. So after you substitute 1, 2 into dy dx, what is that giving you? So that's what the question is asking us to do. So first we have to find dy dx. So we have to use implicit differentiation. So on the left-hand side, we have to use the product rule. So we have the derivative of y is dy dx, and then we multiply this by e to the power of 4x squared the way it is, and then we add y the way it is, and then the derivative of e to the power of 4x squared. So we have, first of all, it must remain the way it is, and then we multiply by the derivative of 4x squared, which is 8x. We do the same thing on the other side. Our first function, 2x, its derivative is 2, and then e to the power of y squared must remain the way it is. Then 2x remains the way it is, and then the derivative of e to the power of y squared. So first it remains e to the power of y squared, and then we multiply by the derivative of y squared, which is 2y, then the derivative of y, which is dy dx. Then we know what to do. All the terms that have dy dx must come to one side. The ones without dy dx should go on the other side. You'll factorize dy dx, make it the subject of the formula. Okay, so we have dy dx e to the power of 4x squared minus, so if we multiply this out, we have 4xy e to the power of y squared and then dy dx. This is equal to 2 e to the power of y squared, and then this term here goes to the other side. We have minus 8xy e to the power of 4x squared. Okay, so on the left-hand side, we factor out dy dx. We have e to the power of 4x squared minus 4xy e to the power of y squared. Is equal to 2 e to the power of y squared minus 8xy e to the power of 4x squared. Then if we make dy dx the subject of the formula, okay, so 2 e to the power of y squared minus 8xy e to the power of 4x squared over e to the power of 4x squared minus 4xy e to the power of y squared. So that is our derivative. And now we have to substitute the 0.1, 2 in it. So now we work out dy dx at the point 1, 2. So that means x is 1 and y is 2. So what we get is 2 e to the power of 2 squared minus 8 times 1 times 2, and then e to the power of 4 times 1 squared over e to the power of 4 times 1 squared minus 4 times 1 times 2 and e to the power of 2 squared. Okay, so this you can work out on your calculator, and what I got is 2. Okay, so we have dy dx at the point 1 comma 2. This is equal to 2. Now, what exactly does this mean? So remember, whenever we're differentiating, finding dy dx, dy dx shows us or tells us the slope of the function, the slope of the gradient of the function at a point, and we know that the slope or the gradient of the curve at that point is also equal to the gradient of the tangent to the curve at that point. Okay, so you can write it like this: dy dx at the point 1 comma 2 is the gradient to the curve. It's the gradient of the curve. Y is equal to f of x, or you can write the equation that we have over there at the point 1 comma 2. Okay, or you could also mention this is the gradient. Okay, so this is an alternative. You can say this is the gradient of the tangent to the curve at the point 1 comma 2. So both of those are correct. Okay, so the gradient of the curve at that point, it is equal to the gradient of the tangent at that point. Right, so now we look at some of the questions in the exercise. So we have exercise 12.10. This is on page 156. So I would advise you to pause the video, try the question on your own, and then look at how I have done it, just to make sure that you are practicing and not just watching the video like a movie. So you learn more by actually practicing. So please pause the video, try the question on your own, and then check with the way that I've done it if you are in fact correct. Okay, number 1 says find dy dx for each of the following. 1.1, we have x squared plus y squared is equal to 2x plus y. Okay, so simple and straightforward. We just differentiate. On the left-hand side, the derivative of x squared is 2x. The derivative of y squared, this is 2y, and then we multiply by the derivative of y, which is dy dx, which of course you know can be written as y prime. They mean the same thing. Okay, then the derivative of 2x is 2. The derivative of y is dy dx. And then you collect your terms with dy dx on one side, those ones without dy dx on the other. So this one can come this side, and this one can go that side. So we will have 2y dy dx minus dy dx. This is equal to 2 minus 2x. Then on the left-hand side, dy dx is a common factor, so take it out. We have 2y minus 1. This is equal to 2 minus 2x. So that leaves us with dy dx. This is equal to 2 minus 2x over over 2y minus 1. Okay, so that is 1.1, then 1.2, we have x squared y minus x y cubed is equal to 0. Okay, so to differentiate x squared y, we have to use the product rule. Okay, so for the product rule, we said x squared the way it is, and then the derivative of y, which is dy dx, and then the derivative of x squared, this is 2x, and then we write y the way it is, and then the same thing over here. So when you have a minus, you need to be careful. You have to subtract the entire derivative. So it's minus, it's best to put it in a bracket like this, because if you write the minus and then there's a plus between the two and you don't have any brackets, then that is not correct. Okay, so you must have your bracket there or put a minus here and a minus between the terms. Okay, so the derivative of x is 1. So 1 times y cubed is y cubed. And then we have x the way it is. And then x is multiplied by the derivative of y cubed, which is 3y squared. And then the derivative of y squared is dy dx. Then on the other side, the derivative of x squared, that is just, so the derivative of x is just 0, okay? So 0 is a constant, and we know that the derivative of any constant is 0, okay? Then we want to collect all the terms with dy dx together. The ones without dy dx must go to the other side. We factor out dy dx, and then we make dy dx the subject. Okay, so I have x squared dy dx. Then we see this one will go that side, this one will go that side, and then this one here, because of this negative, is also going to be negative. So I have minus 3xy squared dy dx. Then y cubed goes that side, it becomes positive now because of this negative. And then this one goes that side, it becomes negative. All right. Then we are going to factor out dy dx. X squared minus 3xy squared. This is equal to y cubed minus 2xy. Then we have dy dx. This is equal to y cubed minus 2xy. We divide by x squared minus 3xy squared. Right, 1.3. All right, so y over x, the derivative, we have to use the quotient rule. That is the denominator, the way it is, and then the derivative of the numerator, which is dy dx. Then we subtract the derivative of the denominator, which is 1, multiplied by the numerator, the way it is, and this is all over the denominator squared. Okay, then minus again here with this derivative, we must put it in brackets because we are subtracting the entire derivative, not just the one that comes first. So the derivative of x is 1, 1 multiplied by y is y, excuse me, and then we add x the way it is, and the derivative of y is dy dx. Then the derivative of -1 is 0 because -1 is a constant, and derivatives, like we said, is a rate of change. So if something is not changing, then its rate of change is 0. So this is equal to 0. We can multiply everything by x squared. So we have x dy dx minus y, and then minus x squared y minus x cubed dy dx. This is equal to 0. Okay, then making dy dx the subject, we have to group them. These two, let's go over to the other side. So we have x dy dx minus x cubed dy dx. This is equal to x squared y. So this one, go to the other side. This one, go to the other side. Then we factorize. So dy dx, we have x minus x squared. This is equal to x squared y plus y. Then making dy dx the subject, dy dx, this is equal to x squared y plus y over x minus x squared. So this should be x cubed. I made it x squared. Okay, so it should be x minus x cubed. And 4. X sine y is equal to y sine x. We find the derivative dy dx. Okay, so on the left-hand side, we have to use the product rule. The derivative of x is 1. Then we multiply by sine y, the way it is. So 1 times sine y is just sine y. And then we have x, x. Then the derivative of sine y, we have cos y. And then we multiply by the derivative of y, which is dy dx. Then on the right-hand side, the derivative of y, dy dx, multiply this by sine x, and then y, the way it is, the derivative of sine x is cos x. And then we collect our terms as we usually do. This one, let's go over to this side. This one can come over to this side. So we have x cos y dy dx. This one, we say it comes over, so it becomes negative dy dx sine x. This one remains on this side, so we have y cos x, and this one goes over to the other side, so it becomes minus sine y. Then on the left-hand side, dy dx is a common factor, so we have dy dx x cos y minus sine x. This is equal to y Then make dy dx the subject of the formula. Dy dx, this is equal to y cos x minus sine y over x cos y minus sine x. (1.5). We have y e to the power of sine x is equal to x e to the power of cos y. All right, so again, here we have to use product rule. So the derivative of y is dy dx, and e to the power of sine y must remain the way it is. And then this time y remains the way it is, and then we multiply by the derivative of e to the power of sine y. The derivative of e to the power of sine y, first it remains the way it is, then we multiply by the derivative of sine y, which is, sorry, not sine y, sine x, which is cos x. Okay, then on the right hand side, the derivative of x is 1. 1 times e to the power of cos y is just e to the power of cos y. And then we have x must remain the way it is. Then the derivative of e to the power of cos y, which is e to the power of cos y. The derivative of cos y is negative sine y. And the derivative of y is dy dx. Okay, then we proceed as we normally do. The terms with dy dx come over to this side, those without over to that side. So this one has dy dx, so it'll remain on this side. Then this one, which is negative, when it comes over to this side, will become positive. So I have plus x sine y e to the power of cos y dy dx. This is equal to, this one remains on this side. And then when this one comes over to that side, it becomes negative. Okay. Then we proceed to make dy dx the subject. So we factorize dy dx. We have e to the power of sine x plus x sine y to the power of cos y. This is equal to e to the power of cos y minus y cos x e to the power of sine x. Okay, sometimes it looks better if you put brackets there, so it's clear that it's not cos of x e to the power sine x, but it's just cos of x. Okay. Same thing over here, but it's the way you write it. Right, then we have dy dx. We have this term here, e to the power of cos y minus, I'm just going to rewrite that a little bit, e to the power of sine x, and then we have cos x over e to the power of sine x plus x e to the power of cos y. sine y. So again, I don't want to write it with brackets here. And when it's e to the power of cos y and then sine x, it's clear that they're multiplying. Okay, so that's why I choose to write it like that. Right, 1.6. We have 4x squared minus 16y squared is equal to 16. So simple and straightforward. We just find the derivative. Okay, the derivative of 4x squared, this is 8x. And then the derivative of minus 16y, this is minus 32y. And we multiply by dy dx. And on this side, we have 0. Then this can go to that side. So we have 8x is equal to 32y dy x, and then divide both sides by 32y. And if I write dy dx first, we have 8x divided by 32y, and leaving our answer in its simplest form, we have x over 4y. Then 1.7, we have x cubed minus y cubed is equal to x squared plus y squared. The derivative of x cubed, 3x squared. The derivative of minus y cubed, we have minus 3y squared multiplied by dy dx. And the derivative of x squared, 2x. The derivative of y squared, 2y. And then we multiply by dy dx. Okay, so because this one is negative, I'm going to take it over to this side, and then this one will come over here. But it doesn't actually matter as long as they are on the same side. So I have 3x squared minus 2x. This is equal to 2y dy dx plus 3y squared dy dx. Okay, so if I rewrite this one here first, you can see that dy dx is a common factor. So we have y squared plus 3y squared. And this one here, we have 3x squared minus 2x. That leaves us with dy dx. This is equal to 3x squared minus 2x. And this is all over 2y plus 3y squared. Two x to the power 4 minus xy minus 4y squared is equal to 0. Differentiate. The first one we have 8x cubed. Here we must use the product rule. So we have minus, the derivative of x is 1, 1 times y is 1. And then we have x, and the derivative of y is dy dx. Then here the derivative is 8y, and then we multiply by dy dx. This is equal to 0. Then proceeding as we normally do, this one has dy dx, this one has dy dx. They can go over to the other side, and I'm going to write the right-hand side first. So if this one goes over to the other side, it becomes positive. So it becomes 8y dy dx. And then this one goes over to the other side. It also becomes positive x dy dx. Then on this side, I'm left with 8x cubed minus y, right? Then we factor out dy dx. We have 8y plus x is equal to 8x cubed minus y, and that means that dy dx, this is equal to 8x cubed minus y over 8y plus x. 1.9 y is equal to ln of x plus ln of y. Okay, the derivative of y, this is dy dx. The derivative of ln of x, this is 1 x. The derivative of ln of y, this is 1 over y, and then we multiply by dy dx. So this one has dy dx. We must come over to this side. Okay, and then we factor out dy dx. Okay, then we make dy dx the subject. Okay, and like I said, we don't like to leave our answers with fractions within fractions. So what I'm going to do is I'm going to multiply the numerator by xy and the denominator also by xy. So here the x's will cancel and I'll be left with y. And here 1 times xy is xy, and then the y's will cancel. I have minus x. Okay, 1.10 with the square root of x plus the square root of y is equal to the square root of xy. Okay, so remember square root means the exponent is half. So when we differentiate, we proceed as we normally do, and remember that square root is a power half. Right, so the derivative here will be half x to the power of minus a half. The derivative here, we have half y to the power minus half, and then we multiply by dy dx. Same thing on this side, we have a half xy to the power of minus a half, and then to differentiate the inside, we have to use the product rule. The derivative of x is 1 times y is y, and then we add x, and the derivative of y is dy dx. Okay, and then we just collect our terms with dy dx on one side. So this one is dy dx, and then when we multiply out, this one will have dy dx. So here I have, okay, even before that, I could multiply everything by 2. So multiply the left-hand side by 2, and then multiply the right-hand side by 2 so that all these halves will cancel. Okay, then it's easier to work with. Okay, then we say this one will remain on this side. So I have 1 over the square root of y dy dx. And then we have to multiply out the brackets like this. So here we will have, it's positive. So when it goes this side, it will become negative, the square root of x, y. and then it's multiplied by x dy dx. Okay, so when I multiply like that, it's x multiplied by the square root and then dy dx. So this one, xy to the power of minus, sorry, it's fraction. This is not right because the power is negative. So it's 1 over the square root of xy. Okay, so on this side, I have y over the square root of xy. Okay, so when you multiply this one, and then this term here that doesn't have dy dx come over to this side, so I have 1 over square root of x. So if we factor out dy dx on the left, we have 1 over the square root of y minus 1 over the square root of xy. This is equal to y over the square root of xy minus 1 over the square root of x. There should be an x here. Sorry, it's this x over there. Okay, then we have dy dx. This is equal to y minus, this is y over the square root of xy minus 1 over the square root of x over 1 over the square root of y minus x over the square root of xy. Okay, like I said, we don't like fractions within fractions, so I can multiply numerator and denominator by the square root of xy, and here square root of xy. And remember, square root of xy, this is equal to the square root of x times the square root of y. Okay, so when I multiply what I have here, y over the square root of xy times square root of xy, this just leaves me with y, and minus 1 over the square root of x, I will be left with minus the square root of y. And then in the denominator, I will have the square root of x minus x. Okay, so this is my dy dx. For question 2, we have to find dp dv if pv is equal to pc plus k. Okay, so we are differentiating p with respect to v. That means c and k, these are our constants. So here p and v are multiplying, so that means they are, we have to use the product rule to differentiate. So the derivative of p is dp dv, and then we multiply that by v, and then the derivative of v is 1, and multiply that by p, we get p. So here, c is a constant, so the derivative of p is just dp dv, and this is multiplied by c, and because k is a constant, the derivative of k is 0. And then we collect all the terms with dp dv on one side. So we have v dp dv minus, maybe I should have done it the other way around. So this one here should go that side, and this one here should stay on this side. Okay, so it'll become negative when it goes over to this side, and then I have C dp dv, and this p here remains positive. Okay, so this one goes over to this side and becomes negative. This one remains positive on its side. Then we factor out, we have C minus B, and this means that dp dv, this is equal to P over C minus B. Then number 3, we want to work out dl dt if L squared plus LT is equal to sine of L. Okay, so to differentiate, excuse me, L squared with 2L multiplied by dl dt, and then LT, we have to use the product rule. So we have L multiplied by the derivative of T, which is 1, and then the derivative of L, this is dl dt, and this is multiplied by T. The derivative of sine, this is cos L, and then we multiply by dl dt. So try not to get confused with the use of different letters. So you should be able to differentiate even if we are not using X and Y. The concept is the same. Okay, so we continue. This has dl dt, so everything can go that side. I have cos L dl dt minus 2L dl dt minus T dl dt. This is equal to L. So this one goes that side, becomes negative. This one goes that side, it becomes negative. And then we have dl dt. This is cos L minus 2L minus T is equal to L. And then making dl dt the subject of the formula, we have dl dt is equal to L over cos L minus 2L minus T. Then question 4.2, 2y cubed plus 4xy plus x squared is equal to 7. And we want dy dx at the point 1, 2. Right, so we will first have to find dy dx, and then we'll substitute x is equal to 1 and y is equal to 1. So doing that, the derivative here, we have 6y squared multiplied by dy dx. And to differentiate here, we use the product rule. So we have 4x dy dx plus the derivative of 4x is 4 multiplied by y, and then the derivative of x squared, this is 2x, the derivative of 7 is 0. So these two have dy dx, those two do not. Let's go over to that side. So 6y squared dy dx plus 4x dy dx. This is equal to minus 4y minus 2x. So we have dy dx, 6y squared plus 4x is equal to minus 4y minus 2x, and that means that dy dx is equal to minus 4y minus 2x over 6y squared plus 4x. Okay, and then to make dy dx, or to find dy dx at the point 1, 1, rather. Okay, so even before that, I see that 2 is a common factor everywhere, so I can divide numerator and denominator by 2. So I have minus 2y minus x, and this is over 3y squared plus 2x squared. 2x. Okay, and now I want to work out dy dx at the point 1, 1. So everywhere I have y, I'll put 1. Everywhere I have x, I'll put 1. So that will leave me with minus 2 times 1 minus 1 over 3 times 1 squared plus 2 times 1. Okay, so in the numerator, I have minus 3. In the denominator, I have 5. So my answer is minus 5. Okay, so that is the gradient of the curve at the point 1, 1, which is also the gradient of the tangent to the curve at the point 1, 1. And 4.3, we have 2x squared minus xy plus 3y squared is equal to 18, and we want the gradient at point 3, 1. Okay, so the idea is the same. The derivative of 2x squared, this is 4x. The derivative here, we have to use the product rule. Derivative of x is 1. 1 times y is y. Then the derivative of y is dy dx. Multiply that by x. The derivative of 3y squared is 6y. The derivative of 18 is 0. Then we collect the terms with dy dx. So here I can see it's negative, so I'll take it over to the other side and then write it first. I have x dy dx. This is equal to 4x minus y plus 6y. Okay, and then dy dx. This is equal to 4x minus y plus 6y over x. I see here, I got something. My bad. Dy dx. Dy dx. Okay, so that changes. Okay, so this one should also be on that side. So we have x. Just rewrite this. Just x dy dx minus 6y dy dx. This is equal to 4x minus y. Then factor out. Okay, and that means that dy dx, this is equal to 4x minus y over x minus 6y. Okay, and now we want to find the derivative at the point 3,1. So we write dy dx at the point 1. This is 4 times 1 minus, sorry, 4 times 3, because this is x and this is y. 4 times 3 minus 1 over 1 minus 6 times 3. So this is 12 minus 1, that gives us 11. And then 1 minus 18, this is, what am I doing? This should be 1. Then 1 minus 6, again. Okay, sorry about that. This should be 3. Then 3 minus 6, that is negative 3. So our answer is negative 11 over 3. Number 5, we have to find dn dt if n is equal to c e to the power of t over n. Okay, so using the implicit differentiation, the derivative of n, this is dn dt. And then here, c is a constant. So we have c, and then e to the power of something. First, it remains e to the power of t over n. And then we multiply by the derivative of t over n. To find the derivative of t over n, we use the quotient rule. So n, the way it is, multiply by the derivative of t, which is 1, and then we subtract the derivative of n, which is dn dt, and then we multiply by t the way it is, and this is all divided by n squared. Okay, we can multiply everything by n squared, so we have n squared dn dt, then multiplying out here, this is nc e to the power of t over n minus c e to the power of t over n. There's a t here. So this t here. And then we multiply by dn dt. And then this one goes over to this side. So we have n squared dn dt plus c t e to the power of t over n dn dt, and this is equal to nc e to the power of t over n. Then if we factor out dn dt, we have n squared plus ct e to the power of t over n. This is equal to nc e to the power of t over n. And then that means that n dt is equal to nc e to the power of t over n over n squared plus ct. Just write that c is capital. Ct e to the power of t over n. Okay, so that is our derivative. Determine the gradient of the tangent to the curve 3x squared minus 7y squared plus 14y is equal to 27 at the point minus 3 and 0. So we know that the gradient to the gradient of the tangent is just the gradient of the curve, which is dy dx. So we have to find dy dx. The derivative of 3x squared, this is 6x, and then here we have minus 14y multiplied by dy dx plus the derivative of 14y is 14 dy dx. And the derivative of 27 is 0. Okay, so these two can, in fact, minus 6 just go that side. Okay, then we factor out. I'm just going to write the positive one first. Okay, and this means that dy dx is equal to negative 6x over 14 minus 14y. See that 2 is a common factor, so we have minus 3x over 7 minus 7y. And this is the same as 3x over 7y minus 7. Okay, so now our gradient at this point, we have dy dx at the point minus 3, 0. We have 3, x is negative 3. And then we have 7 times 0 minus 7. This gives us negative 9 over negative 7. And our gradient is 9 over 7. Okay. Okay, so the last thing in this video will come on higher order derivatives. Now, higher order derivatives isn't a new technique that we are using to find the derivative. All we are doing is we are differentiating multiple times. So we say that if y is equal to f of x, we can work out, okay, we say that, and we have already determined say y is equal to f prime of x. So I found the first derivative. Then it's still possible to find the derivative of the first derivative. So we found y prime is equal to f prime of x. Then it is possible to differentiate y prime to obtain the second order derivative. Okay, and use the following symbols. Say y prime, this is dy dx. Y double prime, this is d2y dx2. And this just means you differentiate with respect to x for the first derivative. Okay, and this of course is also written as f double prime of x. So if we look at an example of this, we have f of x. This is equal to 2x cubed plus 6x squared minus 3x plus 9. We want to keep finding the higher order derivatives. So we start with f prime of x. We differentiate, we get 6x squared plus 12x minus 3. Okay, then we find the second derivative. This is 12x plus 12. Then the third derivative, we write f triple prime. This is 12. Now for the fourth derivative, we don't write quadruple prime. No, for the fourth one, we write it like this. It's in brackets and with a 4 because we can differentiate some functions, you can differentiate them an infinite number of times, and we're not going to write just prime, 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 all those apostrophes like that. So from 4 onwards, the number of derivatives is written as an exponent and in brackets. So like this, and this is 0. And then the fifth derivative, this is 0, and so on. Okay, so with this function here, it eventually differentiates to 0, but like I say, there are some functions like y is equal to cos x that you can differentiate an infinite number of times. So we find dy dx, this is minus the sine x, then d2y dx2, this is minus cos x, then d3y dx3, this is sine x. Then the fourth derivative is this cos x. And you can see this one here, you can continue an infinite number of times, okay? Because the derivative will never reach 0. All right, let's see another example. So we're going to determine d2y dx2 if y is equal to 2x. So we'll have to find the first derivative and then differentiate that. Okay, so this means that dy dx is equal to, on the right hand side, we have to use the product rule. The derivative of sine x is cos x. And then the derivative of e to the power of 2x is 2e to the power of 2x multiplied by sine x. And then the second derivative, this is d2y dx2. Product rule here again, we have e to the power of 2x. The derivative of cos x is minus sine x. And then we add the derivative of e to the power of 2x. This is 2e to the power of 2x, and then multiply by cos x. Same thing over here. The derivative of 2e to the power of sine 2x. This is 4e to the power of 2x sine x. And then we have 2e to the power of 2x. The derivative of sine x is cos x. Okay, then simplify as far as possible, collecting like terms. This means that dy dx, the second derivative, we have these two, they're like terms. We have 4e to the power of 2x cos x. Here we have this one and that one, they're like terms. We have plus 3e to the power of 2x sine x. Okay, then if we look at the questions in the exercise, exercise 12.11, this is on page 157. Okay, so like I said, it is helpful for you to pause the video, try the questions on your own, and then just confirm if what you have done is correct or not. So number one, we have, it says find the second order derivatives for each of the following. A 1.1, we have y is equal to 3x to the power 4 plus 2x squared minus 7x. So we find dy dx. This is 12x cubed plus 4x minus 7. And then the second derivative, this is 12 times 3 is 36, x squared plus 4. And 1.2, y is equal to e to the power minus x cos 2x dy dx. This is using product rule, e to the power minus x. The derivative of cos is the sine 2x. The derivative of 2x is 2. And then we add the derivative of e to the power minus x is minus e to the power minus x cos 2x. Okay, so we can simplify it before we differentiate again. Okay, then we find the second derivative, d2y dx2. Product rule again. The derivative of sine is cos, and multiply by 2. And here this will be minus again. So this is plus. So I'm looking at this as its own function. So now the derivative of this one, we have minus 2e to the power minus x. This minus will come down. So I will have 2e to the power minus x and sine 2x the way it is. Okay, then here I'll leave the minus there. Excuse me. Okay, e to the power of minus x the way it is. The derivative here 2, which should end minus sine 2x. And then we add the derivative of this one, which is minus e to the power minus x cos 2x. Okay, so if I just write it over here, d2y dx2, this is negative, so I have negative 4 e to the power of minus x cos 2x plus okay, and we have 2e to the power of minus x sine 2x. And then here, negative and negative will give us positive. 2 e to the power of minus x sine 2x. And then again here, negative and negative will give us positive e to the power of minus x cos 2x. Right, then you just collect any like terms you have. So we have cos 2x here and cos 2x there. That would be negative, and then these two, they're sine 2x. So when I add them, I have 4 e to the power of minus x sine 2x, and then here I have minus 3 e to the power of minus x cos 2x. Okay, just check and make sure that it is in fact correct. One point three. Okay, so dy dx, you just use the chain rule and then multiply by the derivative of the inside, which is 2x. Okay, if you like, you can multiply this out before you find the second derivative, or just use the product rule to find the second derivative. d2y dx2. This, I just simplified a little bit, 4x, and then this is x squared minus 3. So the derivative of 4x is 4. Multiply that by x squared minus 3. And then you have 4x. The derivative of x squared is 2x. So we have 4x squared minus 12 plus 8x squared. This leaves us with 12x squared minus 12. Okay. Then 1.4. S is equal to ln of sine t. So we want ds dt, that's our first derivative. Chain rule again, we have 1 over sine t. The derivative of the sine t is cos t. So this is just cos t over sine t. It's just cot of t. Then our second derivative, we know the derivative of cot is minus cosec squared of t. And in question 2, we are told that y of t is equal to t to the power of 4 plus 3t cubed minus 4t squared minus t plus 1. And we have to determine y triple prime of t. Okay, so y prime of t, this is our first derivative, very easy to do. We have 4t cubed plus 9t squared minus 8t minus 1. Y double prime of t, this is 12t squared plus 18t minus 8. And then y triple prime of t, this is 24t plus 18. So 3 says if y is equal to minus sine x find the third derivative at the point where x is equal to pi. Okay, so our first derivative, the derivative of minus sine is minus cos x. Second derivative is sine x. And our third derivative is cos x. Okay, so remember that these symbols, they're interchangeable. So even if the test says find d3 y dx3 and you write it as y triple prime, I understand that they are the same. Okay, so then y triple prime when x is equal to pi, this is cos of pi, and we know that cos of pi is equal to -1. Right. Then the last question, we have y is equal to 5x to the power of 6 minus 2x to the power of 4 plus x squared minus 4. And it says to determine for y dx 4. Okay, so we find dy dx. This is 30x to the power of 5 minus 8x cubed plus 2x. Then the second derivative, 150 x to the power of 4 minus 24 x squared plus 2. The third derivative, 150 times 4 is 600 x cubed minus 48x. And then the fourth derivative, this is 600 times 3 is 1,800 x squared minus 8. Okay, and that's it on higher order derivatives.